Now in case of alkene, if I take an alkene and react with X2, here halogen can be either chlorine or bromine in presence of ultraviolet light. Then this allylic carbon, the carbon that is immediate next to the double bond, look at that, these two carbon atoms are sp2 hybridized containing double bond. The immediate next carbon is here, but immediate next carbon here is allylic. So what has happened here? The allylic carbon will undergo either chlorination or bromination to give you what? To give you an allyl halide. Okay, this is a typically free radical substitution reaction. It is what? Free radical substitution reaction. Okay, sure about that? Look at that once more. If you have, look at that, this is called 1-butene. If it react with bromine in presence of ultraviolet light, then bromination happens at the allylic position much more faster, because this position will be what? This is allylic carbon. So one of the allylic hydrogen is replaced by bromine or by chlorine. Sure. So you are getting what? You are getting an unsaturated alkyl halide, or you can get an allyl halide, you can say, much more appropriated. Now for bromination and chlorination, it is much more appropriate to use thionine chloride. And now for allylic chlorination, we can use either chlorine or sulfuryl chloride. And for bromination, allylic bromination, what can we use? We can use either bromine or NBS, that is known as N-bromosuccinimide. It is called N-bromosuccinimide. This compound is like this. So this is the formula of NBS. So NBS is most conveniently used for allylic bromination. It is the preferred reactant, you can say. Okay, you can use either direct chlorination or direct bromination for the direct halogenation for allylic substitution, but it is more appropriate to use sulfuryl chloride and NBS. It can give you what? It can give you better yield. Now look at this position now. Now this compound is toluene, and in case of toluene, this carbon is at allylic in position. So there are 3 allylic hydrogen. If you have 1 mole of each of chlorine or bromine, or you have sulfuryl chloride or NBS, what would happen? Then you have the replacement of the allylic hydrogen, and what will you get? You will get benzyl chloride as one of the product. Here what you will get? You will get benzyl bromide as one of the product. here what you will get same product like that. So you have again benzyl chloride as the product. NBS, what you will have, so this is the various product you are able to get. Okay, in all these reaction what happens, one of the allylic, one of the allylic hydrogen, one of the allylic hydrogen is replaced. So this is what free radical substitution reaction, that is very very important. Now we will see how it actually happens. Now in case of ultralight, what would happen, this will undergo allylic. Okay, this is called homolytic bond fission, and you had formation of this free radical here, and again you have the free radical. So here X can be what, X2 can be either chlorine or bromine. Okay, the reason being that fluorine, okay, it is highly reactive in nature, so it is not used. And iodine free radical, even if they are formed, they immediately combine together to give you iodine. So that's why it is only preferred for chlorine and bromine, for which you can really manage the reaction well. So free radical, this allylic free radical and one of the free radical of halogen, they will what? They will share their unpaired electron, and a bond is being formed here. So that's how allylic substitution would happen. Now look at that, what would happen in case of NBS, that is N-bromosuccinimide. Now N-bromosuccinimide is this. Okay, this is N-bromosuccinimide. Now actually the reaction of NBS, they are carried out in presence of CCl4 as a solvent and in presence of ultraviolet light. Sometimes heating can be also done in place of ultraviolet light, but ultraviolet light is preferred over heating. Okay, sure about that? So what does happen, that if you have taken an alkene, when I say alkene, it should be other than ethene. Why? Because ethene does not have any allylic carbon. So other than ethene, all other alkenes, they have an allylic carbon, so that free radical reaction is possible there. So what would happen if it react with NBS in presence of CCl4 plus in presence of sunlight? You have allylic bromination. Now we have to see how it happens. Okay, so this is NBS. Look at that, this is CH2. And then you have NBr. So in presence of HNO, what happens? And CCl4, because that is a solvent that can be used. This undergo homolytic bond fission. Okay, half fish arrow, it indicate what? Complete arrow indicate one bond pair or one lone pair, but half arrow, this is called half arrow, it indicate homolytic bond fission. So what happens? A free radical of bromine is formed here. And along with that you have free radical of bromine. that free radical of bromine, it react with so what does happen here? So it undergo homolytic bond fission and you have formation of HBr plus free radical of what? Free radical of propene is also formed here. That free radical of the alkene, it will add up with boom. The second molecule of NBS now, it will undergo homolytic bond fission to give you what? To give you free radical of this NBS plus Br2 molecule. Now this Br2 molecule, it will add up to the free radical. So first this bromine is formed and in presence of ultraviolet light, it will undergo homolytic bond fission and this bromine will add up to this. So this is how it happens. Are you sure about that? So this is very, very important. You again go through the mechanism once more so that you can have complete understanding of this. Okay, sure about that or not? Clear? Now in direct bromination and direct chlorination, they can also give you additional product also, but very little. What I am going to say now, what do you mean by that? Let us suppose if I treat this reaction in presence of CCl4, that is a solvent used, you will get major product as allylic substitution, but in minor you will get what? In minor you will get addition also. Okay, so this is the reaction by allylic substitution, that is major product in this case, and this is what the reaction due to electrophilic addition. Why? Because double bond has been removed. So that is the minor product, but that could happen. Okay, this can be major product if what happens that ultraviolet light is absent or heating is absent. Then what will happen? No direct light, so dark, you can say. Dark does not mean there is complete dark. Dark does mean there is no direct sunlight on the molecules will fall, and you have what? You have, I told you already, bromination is what? Bromination is anti-addition product. That both the atom of bromine will add from what? Different side of the double bond. Okay, sure about that or not? Now look at these reactants. NBS is present in all these reactions. That is N-bromosuccinimide. When N-bromosuccinimide react with these compounds in presence of ultraviolet, then all the position that are immediate next to the double bond, they will be undergone substitution, that is free radical substitution, to give you the product. Okay, so you will get bromination in all those substances like that. This is bromination happen here, bromination would happen here also, bromination would happen. And here also bromination happens. Are you okay? So that's how that all the allylic positions, but all the allylic positions can be what? They can undergo the free radical substitution. Free radical substitution. Okay, so the function of the NBS is to provide a low constant concentration of bromine and use of the HBr formed. Okay, sure about that or not? Please check the mechanism of NBS, that is very very important in highly advanced. Are you sure about that or not? Clearly understood now? Okay. Remember that for your knowledge, that to an alkene, that is very very important point, the addition of HBr, HCl, water under acidic condition, alcohol under acidic condition, direct bromination, chlorination, chlorine in water, bromine in water, all these addition reactions, what they are, anti-addition. What they are? Anti-addition reaction, that electrophile will add from one end and nucleophile will add from this other end. Remember that in case of HBr, this is electrophile and this is nucleophile. So addition of both these parts to the double bond happens from two different directions of the double bond. Why? Because double bond containing carbon are trigonal planar. So both the carbon are in one plane. So from the one side of the plane, hydrogen will get added, and from the other side of the plane, Br or Cl or H2O will get added. Okay, memorize one more thing, otherwise go through the previous videos. When alkene react with bromine or chlorine, chlorine and bromine are the electrophile. Okay, no Br plus is formed there. Okay, remember that. Are you sure about that? So please go through these points very very importantly. Now look at the direct chlorination and direct bromination of the alkanes. Okay, now this type of reaction, they are free radical substitution reaction. Second thing is that chlorination is reactive, that primary hydrogen, secondary hydrogen and tertiary hydrogen, they are replaced 1:3.8:5. So you can say that if 1 is taken as the probability factor for the placing primary hydrogen, then 3.8 is the probability factor for replacement of the secondary hydrogen, and 5 is the replacement of what? Replacement of the tertiary hydrogen. But in case of bromine, primary, secondary and tertiary hydrogen, it is called as selective. It is called as what? It is called as selective. Why? Chlorination is called what? Reactive, but bromination is called selective. Why? Because if the substitution of primary is 1, substitution of secondary hydrogen will be 82 times and substitution of tertiary hydrogen will be 1600 times. So here in case of bromination, tertiary hydrogen is preferred 1600 times more than the primary, and secondary hydrogen is preferred 82 times than the primary, and in between secondary and tertiary is preferred 20 times better than the secondary. So all these things you have to memorize so that you are able to give the right answer. So what has happened here? Look at that. Okay, here in case of propane, these two carbon are primary and the middle one carbon is secondary. So you can say that there are primary hydrogen 6 and secondary hydrogen 2. So if you can do chlorination of these two in ultraviolet light, then what can happen? You can have two products. One of the product is what? 1-chloro propane. The second product can be what? The second product can be 2-chloropropane. So what is the ratio of these two products? Okay, what is the ratio of these two products? So there are 6 primary hydrogen and there are 2 secondary hydrogen. So probability factor of primary will be 6 into 1, that is 6, and probability factor of secondary will be 2 into 3.8. So it comes out to be what? It comes out to be 7.6. So total probability factor comes out to be 13.6. So this is product, primary product, this is secondary product. So percentage of first product is what? It is what? 6 by 13.6 into 100. And percentage of second product is what? That is equal to 7.6 by 13.6 into 100. What is 7.6? Probability factor of the secondary hydrogen. And what is 6? Probability factor of the primary hydrogen. So look at that probability factor once more. Primary hydrogen probability is 1, secondary is 3.8. So how many are there? In this case there are primary 6 hydrogen. So 1 into 6 comes out to be 6 is the total probability factor. And there are only 2 secondary hydrogen. So it will be 2 into 7.6. So it comes out to be 13.6 if you add them. So after that you will determine the percentage of primary and the secondary product. Okay, are you sure? So when you get that answer, what are the answer you are able to get? So here what we can say that it is about 44% and here it is 55 and it is 56%. So percentage of product number, that is 1-chloropropane is 44% and amount of 2-chloropropane is what? 56%. Are you sure about that? So in case of bromine, what happens? You can have 1 bromopropane and 2 bromopropane. So what will happen in here? Now in case of bromine, you know that primary, secondary and tertiary probability is 1:82:1600. So this is product A, this is product B. So what can happen in case of propane? So there are 6 primary hydrogen and probability factor is 1. There are 2 secondary hydrogen and probability factor is 82. So it comes out to be what? 164. So total probability factor comes out to be 170. So what is percentage of product A? It comes out to be 6 by 170 into 100. What is percentage of B? It is 164 by 170 into 100. So here the primary product comes out to be 3.53 and secondary comes out to be 96.47%. Now compare its value with the chlorination. Now in case of chlorination, the primary product is 44, but in case of bromination, the primary product is only 4%. Okay, here the secondary product is 96.47 and here the secondary product is 55.9. So look at the selectiveness of the bromination. That bromination is much more selective. Bromination is much more selective in nature. It will rather than go for tertiary and secondary hydrogen. And in case of chlorine, what happens? There are equal percentage of primary and secondary.